interpretation is often very useful when computing multidimensional integrals. This can be done with the help of determinants. Knowledge about determinants also helps in calculating the area of a triangle. Now, let's get deeper into this to know more about determinants. The word determinant means an element that identifies or determines something's nature or that fixes a result. This term is a much more relatable word, particularly when one speaks about matrices. And in this video, we are going to discuss the concept of determinants and the method of finding determinants of square matrices of order 2 and 3. Determinants. It reveals the numerical value of a square matrix. The determinant provides information about the matrix that is useful in solving a system of linear equations and also in determining the inverse of a matrix and many more. What is the determinant of a matrix? This is clearly one of the most important topics in the matrices and we need to understand it very well. Now, how to write the determinant of a matrix A? It is written like this: A between two vertical bars, and it is denoted by determinant of A or the triangular symbol. Do not confuse it with the absolute value or the modulus of A. The determinant of a matrix is a unique number and it can be calculated. If we have a matrix, say P, with elements W, X, Y and Z, its determinant is written like this. The elements will be written between two vertical bars. Another important thing which we need to know about the determinant is that it can be calculated only for square matrices. Yes, it works only for matrices of order 1 by 1, 2 by 2 and 3 by 3, and so on. Now, how do we calculate the determinant of a matrix? Let's see. Let's start with square matrix of order 1. Let A is equal to 2 of order 1 by 1, then the determinant of matrix A is equal to the element present inside it. So, the determinant of A is equal to determinant of 2, which is equal to 2. Now, we shall move on to find the determinant of a matrix of order 2. Let matrix B is equal to PQRS be a matrix of order 2. The determinant of a matrix is defined as determinant of B is equal to determinant P, Q, R, S. So, start with the first element, go diagonally, multiply the elements. So, we get P into S minus, now what is left? Q and R. So, go diagonally, multiply. So, we get Q into R. So, the determinant of B is equal to PS minus Q into R. Always remember the final result is a value. It can be real or complex number. Let's see one problem to understand more. Find the determinant of matrix T is equal to 4, 5, 3, 2 and its determinant is determinant 4, 5, 3, 2 which is equal to 4 into 2 minus 5 into 3. We get 8 minus 15 which is equal to minus 7. So, finding determinant of a 2 by 2 matrix is simple. What if it is a 3 by 3 matrix? Let's see. Determinant of a matrix of order 3 can be determined by expressing it in terms of second order determinants. Determinant can be expanded corresponding to each of the 3 rows and 3 columns. So we find the determinant by keeping the first row as a reference. Now the first element is A. Now this A is multiplied with something. Now what is that something? Here the element A is the 1-1 element which is multiplied with the second order determinant which is obtained after excluding the first row and first column. So what is left? A into determinant of E, F, H and I. Wait, it's not over yet. Then we subtract the product of B, that is B with something. So B will be multiplied with the second order determinant which is obtained after excluding the first row, second column. So what we get? B into determinant of D, F, G and I. To this, we add the product of C with something. Why don't you guess what will we have here? Yes, we exclude the first row, third column and these 4 elements will remain. So, we multiply C with the second order determinant. What is left? D, E, G and H. This is a method for finding the determinant of a 3x3 matrix. A multiplied with this determinant minus B multiplied with this determinant plus C multiplied with this determinant. On solving all second order determinants, we get A into EI minus F into H minus B into, what is inside? DI minus F into G plus C into, what is inside? DH minus EG. We need to find the determinant. So on solving, we get determinant of P is equal to 1 into 0 minus 3 minus 1 into 0 plus 6 minus 1 into 2 plus 8 which is equal to minus 3 minus 6 minus 10 which is equal to minus 19. So this is the determinant of P. Was this the only way to solve the determinant of a 3x3 matrix? Probably not. We will continue this further in the coming videos. Now let's do a quick recap.
Manorama Horizon. Learning made simple.